It's definitely less.
A few fun trips to San Francisco or Boston or whatever.
So I was in Los Angeles last summer for my internship, and then this next summer I'll be in San Francisco.
Cool. Who are you going to be working for?
Capital One.
Oh, cool.
I worked for them last summer, and they gave me a very handsome return offer, and I said, sure. Because it was...
And you like it, that's great.
Yeah, it's fantastic. I really do like
He
it.
decided to just let it go.
It's super chill, especially working out in California.
Actually, in San Francisco?
There's also a file.
It should be accurate.
So they own like 2 floors of a building in San Francisco, but the main office is in McLean, in Arlington, Virginia.
Okay.
But like right in the DC area.
Right. Yeah.
But yeah, they also have a New York City office, and then a Richmond City, Virginia, and they also have a big old thing in Texas, but I think
Why are there 2 numbers?
No.
Oh, never mind. Okay. So this is the count. So this is the number, and then this is the actual, like, what the product is.
Oh, what's up?
I saw 2 numbers. I was a little confused why, but this is the count.
I get
the actual number. You should probably put like a little parenthesis.
Well, yeah, go to the RoboJackets channel. What were you saying?
Where is it? Where's this job?
I think we can. This is what strategy did. There you go. You're live.
You know that.
Sweet.
How long have we been live?
Yeah, how long have we been live?
One
person's watching.
online, so.
Hello, one person watching. Oh, 75 seconds ago. Okay, all right.
Actually,
So that one person might be you.
We'll take it.
Oh, wait, that is me. Oh no, it's just me watching.
Have fun.
Thank you.
Thank you, Todd. Thanks for getting the stream back. Okay. All right. Welcome everyone from the online world. We're gonna continue our presentation just where we left off. Yeah, sorry about the technical difficulties, but we're back. And I'll just quickly go over just object-oriented programming basics again. So we create our own custom data types called objects. They have whatever properties, behaviors we want them to have. Here's an example of just a simple dog class. At the very top, you have the attributes that just kind of define some properties your objects have, and then the methods are for defining the behavior of your object. Mouse. Okay, here's just an example of the hello world, simplest program you can write. At the top, we declared our class. It's a hello world class, and then public static void main is for our main function. Public means that it's available to seen by other classes. Static means that this belongs to the class, not an object or instance of the class, but to the class itself. Void means there's no return type on the function, or it's not going to return anything. And then each main is going to have a string array called arguments, just to handle any command line arguments you want to pass into your program. And then here that's just the command for printing something to console, and we print this string hello world. Just a real simple example of a Java program. Yep. Here's just a quick review of the common data types. We have Booleans. Those are just true, false. Really good for conditionals. Characters. In Java, they accept any Unicode character, so it's more than ASCII. It's kind of nice. Characters are, one example here is just char C equals A. A is used with the single quotes. Those define a character rather than a string. We'll get to those later. Byte is just a very small number. You can see that range there. As we go down, these ranges are going to get larger for all of the numbers. So if you know something you don't want to use is like a very tiny number, and for some reason you want to save space. I know it's not really an issue anymore in modern programming, disk space or memory space, but still an optimization you can make. Similarly, we have shorts and ints. I think the most common decimal value people use is an int. You could use a long if you want to use a very large number. Int's pretty standard though. And then we have, for floating type numbers, we have floats and doubles. Those are just, all your decimal point numbers. So any fractions, anything like that you want to use. Doubles going to give you more accuracy. So in general, I would use that. It can just be accurate to more decimal places, which is nice. As the name suggests, it does use double the storage space as a float does. but you get more accuracy with that, so I would use that. And then we have string. String's actually an object within Java. It's not like a primitive type or anything, but it's very common, so I included it here. Example we have is string s equals hello. Strings can be defined in place via the double quotes. They're handled as an array of characters in the background with some other useful functions like its length or size and other things like that. So these are just the common data types you're going to see. As for operators, here generally all the operators you're going to want to use when writing your programs. We have the arithmetic operations, plus, minus, multiply, divide, modulo, and then we have increment and decrement. Modulo is a very useful operation. Basically, all you do in that one is you divide the quotient by the operand and then take the remainder. So it's very nice for when you want to keep values within a certain number space, because modulating one number by another will guarantee you're in a certain range of numbers. That can be very convenient. There's a lot of cool math you can do with that operator. Below that, we have the relational operators. So these are used for comparing two numbers or anything with a compare to function written with each other. So you have equality, not equals, greater than, less than, greater than equal to, less than equal to. Example there is for two variables. We have, a equals b or a not equals to b. These are used in conditionals when you want to do something depending on what your variables are set to at the time. And then we have your logical operators like and, or, and not. These are used primarily on Booleans within conditionals to do something depending on the Boolean values. And then we have assignment operations. These are just shorthand mostly for the arithmetic operations. If you just wanted to just change a variable real quick. So you could write a plus equals 20, and that would just take the value of a and add 20 to it, which is just the same as doing a equals a plus 20. There's no difference. This is just faster to write. Obviously, we have just the normal equal sign, which is the assignment operator. So that's how you set any initial value to any variables that you want. Below that, we have the ternary, which is kind of like just a really quick if condition. If you know your if's going to result in a returning a value that's consistent. In this case, it has to be the same data type. So depending on the condition, it will just assign a certain value to your variable. So an example here, x equals a less than b question mark 10:20. It used to be that these were generally faster than if statements and branching. I'm not so sure if that's the case anymore, depending on your compiler, but they're always...
The difference in Java, though, an if statement is not an expression, whereas a ternary operator is
Okay.
an expression.
Yeah, someone from the crowd mentioned something very cool. The ternary is an expression while the if statement is not, so that's a nice difference. And then we have the bitwise operations. These are very similar to logical operations. They act on the bits of a number. So we have and, or, not, and XOR. I wouldn't worry too much about these. You can look them up on your own time. Are we still streaming?
Yes, someone was just talking about how the audio was low.
Oh, the audio is low? What if I...
Ross is-
Oh, okay, Ross is doing stuff in the stream. I can just hold the mic closer to my face or something. Sorry about that on the people watching on the stream. Oh, audio is really quiet. Oh, I'm sorry, that random channel YouTube. Okay, cool. So yeah, those are the bitwise operators. They just act individually on the bits within whatever number you're storing. I don't see them used that commonly, but they can do some pretty slick stuff. Oh, I lost my mouse. All right, yeah, and then we have conditionals. On the left, we just have a standard switch. In a switch, you just take in one value and you run it through all of your cases, and if it matches that case, it will perform whatever you've coded underneath that case. An important thing to mention for switches is that you need to add breaks unless you want it to flow through your cases. Generally, that's the best practice you're going to want to use, is make sure you have a break following all of your cases. Otherwise, it will not break. It will just keep flowing through until it finds a break or leaves the switch. Yeah, and then we have just a standard if, else if. So just running through this, we created some variables at the top, and then within the if clause, we have a statement that evaluates to some Boolean true or false. And depending on if it's true or false, it will either do what's in the if or continue on to any other ifs or elses or else ifs if there are any after that. So yeah, that's where a lot of your logic's going to be, is in these conditionals. And another important thing are loops. Now, there's two basic types of loops. There are while loops and for loops. While loops, they continue while a certain condition is true. They are typically used when you want the loop to end on a condition, but you're not sure how many iterations that's going to take. So if you're not sure like how long something has to loop for until you meet like a certain requirement, you're going to use a while loop. And then for loops, they also iterate on a certain condition, but you typically like know it's going to be this fixed number of times. So that's when you'd use a for loop. The top here's an example of a for loop. Int I equals 1, I less than or equal to your input, I++, and that's just going to loop 5 times. And here we have actually the same while loop. In terms of implementation, for loops and while loops are technically completely interchangeable if you want them to be. But generally, the good practice is to use a for loop when you know how many iterations it's going to run, and a while loop otherwise. There is a thing called a do while loop, which will actually run the contents of the loop first before checking if it can continue or not for how many iterations. So that can be nice if you want to like guarantee something runs at least once in your loop. Back onto classes. So a class is a blueprint for an object. Just consider our earlier dog class. It demonstrates that our theoretical dog has several properties. These are the attributes up here, and certain actions. These are the methods we defined in here. But in order to put those into fruition, to make them actually do something, we need to instantiate an object. So objects are instances of classes. So the class is just a blueprint for that object, and the instance itself, the object, is actually what happens when you create one. So to make that clear to everyone, imagine there's this factory producing toy dogs, and the class on the top here, top image here, contains the properties and actions that this dog toy may or may not have. In this case, an object would be one specific toy dog produced using this template in the top right. So line 3 in the bottom example is a specific dog called dog1. So that's an object right there, dog1. What we use is we wrote a class to create that object. So right now, this dog does not have any of its properties set, right? So does anyone know how would we go about setting its properties? Audience question. Yes.
It depends on if the variable is private or public.
Yeah, but just like when instantiating the object, what would we use to feed in some values to it?
You would use arguments.
Yeah, but to do that, we'd have to write very... You're on the right track. What I was looking for is constructors. We need to create a constructor to be able to pass in data when we instantiate an object. So a constructor is just a special method we use when creating something. So in it, we can define whatever values we want to pass in to fill out its attributes. So in this case, the dog constructor, it has a string for its breed, integer for its age, another string for its color. An important thing to remember with constructors is if your arguments to the constructor happen to be the same as the attributes to your class, you're going to need to use the this keyword and then dots whatever the attribute is, because otherwise the arguments in your constructor are going to overload those in the class and they will not be set. So in this constructor, if I just did breed equals breed, age equals age, color equals color, it would not set any of my actual attributes to the class. You need to use this dot breed. Yeah. Now, if they were different names, like if all the variables had different names, that could work. It's not very standard or good practice, but you could do that. So yeah, those are constructors. Here we use our constructor on dog 1. So we created a dog that is a husky, 3 years old, and is white. So yeah, there's just an example of using the constructor. It's just the same as the method name, same as the class name, my bad. Okay, I'm gonna pass on to Matthew, talk about some FRC background.
Hello. Yep, okay, cool. So, the main thing that you're going to be dealing with when you're programming FRC robots in Java is called the WPI lib. The WPI robotics library, or WPI lib, is going to be the main library you're working with, whether you're using C++ or Java. There's a link there that shows you it's a good resource for if you need to look up some things about the library. So basic things like the software tools like the driver station, or more advanced things like vision processing or network tables. And the WPI, the Worcester Polytechnic Institute, it gives a modified version of VS Code, Visual Studio Code, which is an IDE, which lets you develop programs, and you need this particular WPI version of VS Code to program your FRC robot. It comes with a bunch of different things pre-installed and pre-configured so that you can properly program your robot. Next. And so to get started, you go to this GitHub link, github.com/WPI lib suite, all WPI lib releases. Yeah. So currently the last year's version is up, but this year's version should be out soon. You find the most recent version and download it, and make sure you select the correct operating system and architecture. So most things would be like Windows 64-bit, but whatever your computer is. Then you go to this link for a guide for opening the disk image and stepping through the installer. And then with that, you will have the special version of VS Code all up, and it should come with, you should know it's correct when you have, you can open it and see the WPI lib extension, which is the thing you're going to be using to create the project. Now on to some more general things. So there's the two different game sections in all FRC games is the autonomous section and the teleop section. You saw on the video that they were talking about on the autonomous section. The thing with autonomous is that there's no human input allowed. You click a button to make the robot start, and then you just don't touch anything for 15 seconds. The drive team selects which autonomous command to run before a match. So you can have multiple different autonomous commands. So usually a strategy is to have 1 or 2 different autonomous paths for each starting position, so that one, that you can place your robot in any position and have a path planned for it. And then you want to have multiple paths for each starting position, so that if one team is like, hey, we're going here, then you can be like, okay, we are going to select a path that does not interfere with that. A general strategy. And the selected autonomous command is the only thing that runs in the first 15 seconds. So you can't change the autonomous command that you're running halfway through. It has to be that one thing. And then after autonomous ends, they give a countdown, 3, 2, 1, start teleop. And then you run the teleop command, which is a command that is actively reading from the controller inputs to control the robot and do things. And then during the last 20 to 30 seconds of teleop is the end game, where you have to do something crazy, like have your robot climb monkey bars, stuff like that. Do we have questions from chat? No, cool. Now, the basic unit of code in an FRC project is going to be something called a subsystem. So you can see that it's a class, and it's a class that declares all the different parts of a subsystem of a robot. So, for instance, as this one is showing, the drivetrain is a subsystem of the robot. You want to, have a bunch of commands for your drivetrain, like set speed, set turn, brake, bunch of different things. And so you declare the motors and sensors objects that you're going to be using. So you can see in that massive list of imports in the top right, we're importing some different motor classes and sensor classes that this subsystem is going to be using. And in the bottom right, you can see that they're being declared and assigned. So left motor front is robot map, left drive motor front. The robot map is sort of a file that you have in your project that defines, it's a mapping from different inputs to motors and whatnot. So it's a single file that lists out, here's these motors and here's these motors and sensors, and it points to them, and so you can grab that RoboMaps data and use it in your subsystems. Is the idea. Any questions so far? Cool and good. It's white. And so here's an example of the drivetrain subsystem. So it extends subsystem base, which is slightly different from subsystem, but not too much. So we have this, we're declaring the differential drive object, and we have these WPI Talon FXs, which are motor controllers, I think. Yeah, they control the motors, so they are effectively the motors. And we have a bunch of declarations, so like max power change, max output, a bunch of different variables that we're declaring. And then the constructor on the right, it sets it initializes all of those falcons. It creates a config object, and then sets that config so that it uses the integrated sensor. And so it's just telling all the motors, use your integrated sensors. And then the follow command is an interesting one, in that you're basically telling the motor, copy what this motor is doing as best as you can. And so, if you have 4 wheels driving, you want the left 2 motors to do the same thing, and you want the right 2 motors to do the same thing. And so that's what the follow command is for. And that's why they're called main and sub. So you tell the commands to the main one, and then the sub just follows. And then this, it says this wraps the motors, and so this is an idea in programming called a wrapper, which is basically, collecting a bunch of smaller objects and putting them into one bigger object that you can then control more easily. And so you know, you have all these different motors and you put them into one single object that you can have commands that are like move forward, turn left, whatnot. We set deadband to 0. A deadband is a concept where for the controller, you might not want the tiniest little minute change, like in joystick to like cause the robot to start moving. You might want like a small radius where like it doesn't move. And this is both for control reasons and also for energy reasons, because you don't want to be driving a motor with very little power, like not enough to start the wheels turning, because that's like, that wears down the motors a bit. You only want the motor to be like set to a certain power that it can start moving and not anything less. So that's an idea. Set slow mode. I don't know what that does. It sets the slow mode. Yeah, it's some custom method we've defined that's like, we want the robot to move slow. Drive set right side inverted. So you might, the motors might be configured in such a way that they are the opposite direction of movement from the left side or whatnot. And so you might want to change that. And then our neutral mode. Neutral mode usually is either brake or coast. So if we tell the power 0, or like set it into neutral mode or whatever, does the robot coast along or just like keep rolling, or does it attempt to brake and stay right where it is? So those are some different config things. We keep going.
I always thought you wanted to have a non-zero deadband motor, that it was difficult for the motors to get like oscillations or crazy stuff happening if you didn't have some period of time for the deadband. Am I wrong about that?
Your deadband to, yeah.
That example where you had to set the 0 is probably not what we want.
Yeah, that example where we had the deadband set to 0 was highly sensitive in terms of our controller. So even if like we set the controller down, there's a chance it would still like be pushing the motor slightly.
Okay. All right, I'm not trying to interrupt your flow, but
Yeah. In general, though, I think that program was for a very, very slow chassis where it had a lot of torque. So they wanted very sensitive controls in that case. So
okay.
just showing it could be done when you want it to. It all depends on what you're trying to do.
Could have given us a bigger mic. So here's some examples of like this, some functions that are like in that wrapper that we had. So set motor powers, so left power desired, right power desired. Note that it says desired because sometimes the you're not going to be able to get quite what you want, and we'll cover some ways to fix that later. But so the first thing it does is sort of filter out bad input. So you can see at the start, left power desired is math max, math min 1, left power desired -1. What this is basically doing is restricting the input to -1 to 1. If it's anything beyond that, it just gets capped down to whichever one is closer. So this makes it, because usually motor powers is defined between -1 and 1, where 1 is the maximum possible speed. And so you don't want to be sending the motor controller a value of 2 because it might not know how to handle that. This display the power we're asking for uses something called a smart dashboard. And so the drive team that is controlling the robot will have a laptop that has something called smart dashboard open, which is a configurable UI that lets you put up a bunch of different data. And so the smart dashboard, you can put number, which basically displays this number on the screen wherever you want it. And so it's a good idea to like have on the screen, hey, our robot is trying to move at this speed and this speed. And then
You guys have this code on GitHub?
We have a GitHub link later on. Yeah, there's a GitHub link later on in this presentation.
Oh, thanks. All right.
It's for an existing FRC. One of our team members did it, and they just shared their code online.
And so this left power desired and right power desired is multiplying. It's multiplied by the current max power. So that's sort of yeah. It's the percentage of max power that you're looking for. And so then you get divide by current max power because
You don't have to go through
it's
the
whatever.
line.
It's whatever. So yeah, just a bunch of different power control things happen here. Basically, some more smart dashboard things. It's easy to get once you read into it.
I think the key here is to use the smart dashboard to give yourself feedback on what the heck your program's doing.
Yeah.
Yeah.
So smart dashboard's good for debugging things and figuring out, what values are being sent in your code. And on the right are some getters and setters. Not quite, but whatever. So we're getting the sensor positions, and then we can also set fast mode and slow mode. So fast mode means that we can allocate more power to the motors and go speed, or we can go slow mode and go slow. Also, some other things you might want to look into with robotics is a thing called an IMU, which is inertial measurement unit, I think. It gives you roll, pitch, and yaw, which is sort of like your orientation. So this is yaw. Usually you're probably only going to be caring about yaw because that's how much your robot's turning like this. And then there's encoders, which is a thing that you can attach to an axle, and usually a motor axle, that counts how many steps it has. And so steps might be a unit smaller than degrees. It usually is. And so that's a way to measure, how much a motor has rotated, and also you can use it to measure the rotation speed and how fast or how far the robot's gotten by multiplying by the wheel's diameter and all these different things. And so those are some useful things. Do we have questions in chat?
No questions. You're good.
Cool and good. All right, now we're on to PID, the scariest thing. So you can see some math at the bottom. How many people have taken calculus? It's a good amount of calculus. Remember how I said earlier, it's like sometimes you might not be able to reach your desired value, but we have ways of fixing that. This is where PID comes in. PID stands for proportional, integral, and derivative. And the idea is that you have some system that you know what your target is, and you know what your current value is, and you have some way to control where your current value is. And so what we have at the bottom is our output, and the E of T is our current error, basically. So what is our error at this point? So it's our target minus our current position. And so the proportional part is saying if we're very far from the target, we should be moving more towards the target. And so that's the simplest part of PID is like, setting the motor power proportional to the distance of your robot to your target is the idea. And so that works in a lot of scenarios, but not too many scenarios. Sometimes you need integral, and the idea of integral is that it is summing up all previous errors and then multiplying that by the integral constant. and that is the motor value. And so the idea of that is that sometimes, well, not sometimes, always, there's this little thing called friction, which prevents you from making very small movements. And so your robot might be able to get very close to your target, but due to friction, that proportional is not enough. Like it presses a threshold where friction prevents the robot from moving that last little bit. And so you have integral to come in, which is a constantly increasing value as long as you have not reached your target. And so that will eventually push you over. The problem with just proportional and integral controls is that you will overshoot because the integral will become too powerful by the time you reach your target. And so you'll have to tune that, but also you can dampen like any super strong output by using the derivative, which is taking the derivative of the error and using that as a part of your power output. And so that will make it so that you can, if the error changes is changing too rapidly, you can say slow down just a little bit. Don't go that fast. And so that's an incredibly simple and not too accurate, but accurate enough assessment of what PID is. And also sometimes you'll have a bias. Like in general, when you're dealing with like some motors, you might have a bias, which is just a base value. So for instance, if you have like an elevator system, to keep like the elevator in a certain position, you might have your motor have a bias that is just constantly sort of rotating it up to fight gravity, and then have a PID system on top of that that allows you some variation. But that's the idea of a bias. And here we have a pseudocode. Obviously, question? Okay. And so, obviously with computers you can't really do calculus, so we have to do some discrete math. And so here's the idea. You can do that. And then the other part of PID is the painful part, which is PID tuning, which is basically finding values and then running the robot, see what happens, change the values, run the robot, change some values, repeat until you get the desired result. There are some guides out there on how to do some quick and fast PID tuning with robots, but generally what you're going to have to do is just try and error it.
If you want to learn more about PID and tuning, there's a separate controls workshop that goes into more detail, and I believe they have a demo on it too, if you're just curious. So maybe look out for that. This is something you're interested in, something you want to learn more about.
One thing in the pseudocode, that iteration time variable really is a function you're calling to get the current time.
Could you repeat that, please?
I see the iteration time variable in a while loop. Is that really, that be a function that's returning the current time? No?
Probably. Yeah, this is just kind of code to get you.
Yeah, it's a pseudocode, but it's not a variable, though. That's a function, right? Because that while loop is operating over time, and the T and all the things we're doing is time itself, right? Which continues to march forward.
Yeah, you could handle that depending on how you
Well, tell me if I'm wrong. I'm asking you a question. I'm not telling you how it should be.
Yeah, this was just so people can understand kind of the basics behind the
All right, we can move on if you don't want to cover that right now.
We have unscrupulous actors in our chat. Now we're on to commands in FRC in the WPI lib. Commands is basically a higher, more abstract version of a function, which is basically you tell the robot to do something and it will do it. And so they are a class. And so you tell, and you can bind commands to buttons and whatnot. So you can have like the A button on your controller be like shoot ball. You could have X be like shoot ball farther. Y is extend the thing, whatnot. And so you can see that it's a class. You have to define some things. So in the basic constructor, you tell the robot, or you tell the code which parts of the robot this command requires. And the reason you do this is so that different commands that both use the same part of the robot can't run at the same time. So you have a command that uses the drivetrain and another one that uses the drivetrain, and A is running, and you start B, then I don't know if A gets canceled and B starts, or B just doesn't start. It's either or. It might be configurable. But either way, A and B will not run at the same time. And then the rest is some, like you have initialize, which is like what is called before the thing starts. Execute is secretly a loop. It just is called repeatedly until is finished returns true. And so it'll run execute is finished, no. Execute is finished, no. Execute is finished, yes. And then it calls end. And so that's the sort of idea of it. And then autonomous is much the same thing, except it's longer and is less, it's a string of them. And so you call different commands while it's happening. I think the second slide does it better. So you can see that you are doing you're adding a list of commands that are happening. And it's either add sequential, which means that, this command starts and then it finishes and then the next thing happens. Or add parallel, where it will run in tandem with as the previous command. And so, sometimes you want to do two things at the same time with your robot, and that's what add parallel is for. And so that's the idea with autonomous. And here's a bunch of links. Is this the last slide? Pretty sure. No. We can go back. Absorb these links into your eyes. They're useful.
There's the GitHub source for the example code. It's 1261's code base from 2018. So they were a pretty good competition back then. So you can check out their example code if you want to see how they program their chassis and such. They'll probably still be relevant.
Yes.
There have been some breaking API changes, but they are relevant.
And then some words of advice. Read the docs, read them carefully, and also read it slowly because it can be overwhelming at times. Look around for example templates in the project directories when creating a new robot. So when you download the version of VS Code, it should come with some examples. They're very useful to look through to get the general understanding of a structure of these sorts of projects. And don't forget to be creative and try and find new ways to solve these problems. Because what else is robotics about but trying to find solutions to problems? And that is it. Any questions? I see none, so I guess what are we doing?
Well, there are currently no online questions. We're going to let the stream linger for just a couple more minutes in case anyone has any questions for the chat. Yeah, so I'm just going to give the chat just a chance to ask any questions if we have any of the online people wanting to oh, question, yes.
Where can we find more information for the use of TID? Do we just use some of the same links that
Yeah, we have, if you go to the RoboJackets YouTube page, we have a controls workshop, and that will go into more detail about PID if you want to learn more about that. There are a lot of great resources online. Google's a very good resource. Just Googling PID will get you a lot of pages that goes into great detail about PID also. Yeah. Anyone have any more questions? Any from chat?
I know one of the problems that the software people have is simulating the code because they don't have access to the robot because it's getting used by the people practicing on the RC controllers a lot.
Mm-hmm.
Any suggestions on how to simulate your code?
I know personally I use a simulator called Gazebo for running emulations of my robot. That's very nice because it has built-in plugins for something I use called ROS to develop robotics.
Oh, right.
I don't know how helpful it would be.
WPI Lib has some of those things available as
Okay.
well.
Yeah, but
I guess I just wanted to tell the kids that they should use that.
yeah, if there are emulators that you can use to control your robot like virtually, that's really great for debugging and practicing things, and without ruining your robot by doing something wrong. Yeah, that's definitely worth setting up if you can.
Is Gazebo a visual simulator?
Yes, Gazebo is a visual simulator. Yeah.
WPI Lib isn't quite that cool, I don't think.
Okay. Yeah. All right, we're gonna end the stream now. Thank you to everyone who watched.
Thanks, guys.
You guys should stop streaming now. All right. Yep. If anyone wants to stay here and has any questions about setting up the VS Code, I can help them with that if they want. Otherwise, everyone have a great day. Yeah, question.
Is VS Virtual Studios?
VS is Visual Studio.
Oh, yeah,
It's just, yeah.
Yeah, you'll want to go to the WPI site and download their version of VS Code because they have like plugins already installed for you and stuff. You may already have VS Code installed, but
WPI has very nice plugins.
it's sort of complicated for you to take your vanilla VS Code and get it to the where you want it to work with WPI Lib. It's better just to download their version and install it directly.
Mm-hmm.
But you could fight through it and get it to work, don't get me wrong.
I'm betting if I just hit stop streaming. All right, have a great day, everyone.
Take the controls class back.
Yeah, because I just. I'll come out in a second.
Talk to your dad, he's a cool guy.
So is there like a specific one I need to download?
I would download the latest one. I think 2022 is actually out.
Yeah, we're not gonna go back there, are we?
I hope not.
You wanna make sure you get the 2022 version.
Yeah. All right. Yeah, I would use that one.
But if you go, I'd start from their GitHub page, but you can also just, there's a bunch of ways to get there.